Hello and welcome. This is Unit 12, Lesson 2. And we're going to be taking a look at how to find the area under the curve if we are looking at not whole number standard deviations. So for example, in the last lesson, I might have said, find me the area under the curve within one standard deviation of the mean. So we should remember that that's 68%, so 0.68. But what if I said, like, find the area under the curve within 1.5 standard deviations of the mean? We don't know the exact area unless it's at a whole number like 1, 2, 3, or negative 1, 2, and 3. Okay, so that's what we're going to look at today. And we are going to be using our calculator to find that. As you progress into actual calculus, you'll learn how to find areas under curved objects algebraically by hand. That is not something we need to be doing right now. We need to know how to set it up and to plug it into our calculator. Now, if you don't have your own TI at home, that's okay. You can still be part of these notes and just be watching as the buttons I press. It's just a matter of remembering which buttons to press. So then you can come back and try it out on your own. Okay, so let's talk about corn chips like Fritos. So it says a corn chip factory packs chips in bags with normally distributed weights, a mean of 12.4 ounces, and a standard deviation of 0.15. So whenever you're given a new scenario, you always want to draw at least one curve and label it. If you're a very visual person, you might want to draw a new one for each different situation and shade the area. But as long as you have one set up without numbers, you're good to go. So we said our mean was 12.4, and we always label, let me make this a little bit narrower. We always label 3 to the right and 3 to the left, don't forget. Okay, so I'm going to add, so 12.55, 12.7, 12.85, and then 3 to the left, subtracting that standard deviation. So 2.5, 12.1, and 11.85. Okay. So my question now says shade the region that indicates the bags that contain less than 12.64 ounces. So here's what I'm talking about. That's not one of the standard deviations, okay? It's a number, it exists, it's within there, but it's not any whole number. It's not one away or two away. It's like whereas the 12.64 is right here. So it's 1 point something. So guys, that's a z-score. Remember, z-scores and standard deviations are the same, but when it's not a whole number, I need to use another way. Those percents aren't going to work. I can use those to ballpark, okay, from like here all the way over to the first standard deviation is going to be 50 plus 34, so 84%. So I know it has to be bigger than that, but I don't know for sure. So what we're going to do is we're going to use our calculator's normal CDF function to find that area. Okay, and it says state the percentage. So we're going to change our answer to a percent. Remember, you're going to be looking for either percents, decimals, or how many. Okay, so now just draw this down and I'll tell you what it means. We're going to fill this in. So this is something where most of the calculation is done on your calculator, but you actually need to tell the calculator what to do. So this is how you would show your work, writing down the commands that you put in. So if you get the wrong answer and you put the wrong stuff in, I can at least see why. So let's think about this. What this means, the arrow down is saying your lower boundary. So we're telling our calculator, hey, find the area between these two numbers. Okay, the arrow down is your lower. The arrow up is your upper. The mean is the mean. So we said our mean in this problem was 12.4 and our standard deviation was 0.15. Okay. Now we're going from 12.64 all the way down. So when there is not a second given number there, we want to be careful with what we use. So I'm going from something really small to, take into account any outliers over here up until 12.64. So whenever it's like that, I always use negative 9,999. Is that overkill? Absolutely. We know that my numbers are not going to be down there. I mean, honestly, if I use 0, it would be fine. But that's a number I'm never really going to probably be using in normal curves. So just to keep it uniform, I just use the same number, just so like as my scale shifts around, I don't have to think about, oh, okay, like 0, that might not work this time. Let me find a new number. So I just use that. Okay. Yes, I realize my comma's in the wrong spot. The upper boundary is 12.64. So what I'm saying is, hey, find the area from this negative 9,999 up until the 12.64. So how do we get that area? So in your calculators, first turn it on, and you can jot down the steps even if you don't have your own calculator. You're going to look for it. You're going to see this VARS button? It won't okay, I put a red dot on it. Above that is the word distribution in red. Okay, normal curve is a normal distribution, how data is distributed away from the mean, okay? So since it's in blue, I'm going to hit second VARS, and it'll bring me up to this menu. We're only going to be using options 2 and 3. The majority of the time you're using option 2. There'll be a couple of questions here and there where we will use option 3, but we're going to use option 2. So hit enter. And we're just going to type in those values that we just stated. Okay, our lower boundary was negative 9,999. Our upper boundary was 12.64, and I've been using this calculator to do a couple problems so you can see my mean and standard deviation actually were already in there. Usually it saves them for you. So if you have a few questions on the same information, you don't always have to retype that. So go ahead and paste, and then hit again, enter on the home screen. So 0.9452, okay? So we said it was going to be above the 84, was it 52? Now it's asking for a percent, so change that to a percent, so 94.52%. So what I always do is I just write down the 4 numbers, and then if I change it to a percent, I have 2 numbers after. If I don't, I just have a 4-number decimal. All right, it says, the next one says, on the graph at the right, label and shade the region that represents a bag between 12.1 and 12.76. Well, 12.1 was a standard deviation, okay, that was 2 below. 12.76 is not. I mean, if I said between 12.1 and 12.7, you could just use percentages that we learned, because sometimes that's easier. It's less work. It just depends on how comfortable you are with your numbers. And then we had, this was 12, so it's like somewhere over here. Okay, so I'm asked to find this whole big chunk. And the question says, find the probability. That means give me my answer as a decimal. Since it's between 2 values, those are just my lower and my upper. The only time we're going to use like a negative 9,999 or positive is if you only have 1 number given. You're saying like here and lower or here and higher. So our mean once again was 12.4. Our standard deviation, was 0.15. Okay, so I can just go ahead and type this data into my calculator. So once again, I'm doing second VARS, option number 2. Okay, so my lower this time was 12.1. My upper was 12.76. And then I can just go and hit paste. 0.969. So that's the probability. So a pretty high chance that it's going to, you're going to get a bag of potato chip or corn chips that fall within those that weight. So then it says, if the convenience store ordered 370 bag of chips, how many would you expect? Remember, for how many you're doing the area times the total, like total sample size. This store ordered 375, so I'm doing the 0.969 that we figured out times 375. Usually in these problems, when I'm asking how many, we round down. Okay, we never round up. So about 363 bags. Right now, if this was one where you weren't sure, like, which way do I round? I would take either. Like, if that was a 363.92, I would take 364. If it was multiple choice, I would not give you both options. Just pick the one that, that matches, either 363 or 364, whatever is there. All right, let's try one more problem. Unicorns, they do exist. Okay, so there's 972 unicorns. We'll probably use that later. The average is 10.1. The standard deviation is 1.04. So I'm going to add that each time I go to the right. And then I will subtract that each time I go to the left. So 9.06, 8.02, and 6.98. All right. So shade the region that represents a probability of a unicorn's horn being longer than 9 centimeters. So that's just a little bit above 1 standard deviation below. Okay, so it's like, if here's my 1 standard deviation below, well, okay, that's not a good picture, but you get the idea. It's there. So it's going to be more than half. Calculate the area. I'm saying, hey, find me the probability. That's what I mean by area. It's the same thing. It's giving me it in a decimal form. So we got to do lower, upper, mean, and standard deviation. So my lower boundary is the 9. Now, kind of think back to the problem on the other page. I don't have an upper boundary. It's going on forever. Now, 50 probably would be high enough, let's be honest, but just to keep it uniform, I just use this every time so that if my scale's in the thousands, I don't have to worry about it. I just always use the same thing. We said the average was 10.1 and my standard deviation was 1.04. Also, the bigger number, the more likelihood that I didn't miss something, that there wasn't an outlier, because maybe there's a unicorn that has a 50 centimeter horn, and I could be chopping him off by not incorporating him. So the bigger the number, it's just easier. All right, so second VARS number 2, once again, we said our lower was the 9. Our uppers are positive 9,999. Average is 10.1, 1.04. Paste and hit enter again. So 0.8549. All right, and once again, area gives me a decimal. And the next problem says, what's the probability? I'm asking you the same thing. You don't need to redo the work. I just want to make sure you realize that area probability, same thing, okay? Of the herd, how many fall into the situation? So I'm going to take that decimal and I'm going to multiply it by 972. Where did I get 972 from? It told me in the beginning of the problem there's 972 unicorns in that herd. There's a lot. So about 830 unicorns. Now, in this one, if you told me 831, it's fine. I've just always been taught in a problem like this to round down. So just because technically you don't have that extra 0.04 of a unicorn. Just saying. All right. On the graph at the right, shade the region that represents the probability of unicorn's horn being longer than 10.5 or less than 9.5. So there's two different ways that we can attack this. So I'm looking at two separate regions. So what you could do, here's option number one. This isn't the option I'm going to do, that I would do. I'm going to do it right now, though. But for option number one, I need to find the area of both sections, and then I need to add them together. So for the 9.5, I'm going from negative 9,999 up to the 9.5. My mean is 10.1, so it's still the same situation. And then I would find the area of the upper side. So that one's going to be from, sorry, lower will be the 10.5 to positive 9,999. So option one is when there's like it's two sides and the missing part is not shaded. Find the area of each individual side. I'm just going to do it on my handy dandy in-hand calculator, just to be a little bit quicker because I'm running out of available time to record before a bell rings. Sorry. But I'm just typing the same thing, guys, that we've been typing in. Went to second vars, option number 2. I'm typing it in, and I'm getting an area. Okay, and it gave me 0.2819 and lots of other stuff. And then I type in this second area, and I type in the 10.5. So this right here on my paper is my work. Now it's just a matter of typing it in. And I got 0.3502. So it's telling me find the area of both parts, so we need to add them together. So 0.2819 plus 0.3502, add them together, plus 0.28, and you get 0.6321. Okay, so that's the area of that. Option number 2. Think the other part of the graph. Find this area that I'm shading in blue, the area that doesn't exist, and subtract it from 1. Why 1? Because the area under the entire curve is 1. So as opposed to finding two individual pieces and adding them, I can find the piece that I don't want and subtract it from 1 because that's going to give me everything else. So I can just do the 9.5 to the 10.5, oops, upper 10.5, get that area. Let me type that in. The mean standard deviation is the same. And I get 0.3677. Now, because of rounding, these two answers might be off a smidge. That's fine. Just show me your work. I'll know what you did. No big deal. And I'm going to subtract that from 1, and I get 0.6322. So it's, you know, 10,000th off. It's fine. Okay? It's the same answer. So either way you want to do it. Personally, I like to do the option I did in blue because there's less things I have to, worry about, but it's up to you. So what percent? So we'll say it's about 63.2%, okay, 0.21, 0.22. Of the herd, how many? So taking that decimal and multiplying it by the 972. And you get about 614 unicorns. All right, now the last piece. In order for a unicorn to be in the parade, we're picky here, guys, okay? But her horn must be in the 75th percentile. So remember, that means that 75% of the unicorns must have horns shorter than hers. On the graph at the right, shade that region, and then we're going to find it. Okay, so this is 50%, so 75 is like somewhere right here. So we're saying, what's this area right here? Okay, well, we know what it is. It's 0.75, because if this is a percent, 75%, it's 0.75 for the area. So what we need to find out is what value is that? Okay, what is the value there? Not necessarily what is the z-score, but what is the value? Okay, so what we do for this option is, in this case, we use second. We go back to that VARS, same menu, but here we're going to use number 3, inverse norm. And what it's going to do is when I type in the area, meaning change that percent to a decimal, do the Beyonce, and let me show you. Okay, I type it in. Area is 0.75. We said the average was 10.1 and 1.04. And enter. And this will give me the horn length, 10.8. So in order to be in the parade, your horn has to be at least 10.8 centimeters. Okay, so those are the only 2 options we're going to do. We're going to use number 2 most of the time to find out area probability, and then from there I can ask you how many. All right, or if I'm asking you, hey, here's a percentile, find me what value goes there, you do this, okay, which is option number 3. And that is all.